Welcome back, everyone. I'm Dr. Abhinay Andamani from University of Florida and NFRE sequencing. In the last section, we learned how a farmer can take manual control of irrigation using a push button, just like a smart switch that toggles between the dry and irrigating modes. Today, we will take our project one step ahead by visualizing the soil moisture levels using color-coded LEDs. I welcome you all to the session 5, Simulating the Soil, RGB for Soil Moisture Levels. In this session, we will learn how to represent the different soil moisture conditions using the light emitting diodes of various colors. We will also see how an Arduino reads the sensor data and decides which color to display, giving farmers a quick visual view of their soil health. Sounds interesting, right? Yeah, let's make our circuit more intelligent and colorful. Let's understand the concept first. We have already used a soil moisture sensor in our previous sessions, and we know that it has three different pins: VCC, ground, and the signal pin. So it gives the analog readings that vary based on how much water is there in the soil. So red for dry soil, yellow for ideal moisture, and green for overwatered soil. In this way, the farmer doesn't need to um, read the numbers, rather, they can just simply look at the color and know the condition. With this analogy, let's go to the Tinkercad and start designing our circuit. Go to tinkercad.com and click sign up. Create a personal account and then try to sign in with Google. Click Create Circuits. Always give it a name for your project. All the circuits you design in Tinkercad is auto-saved. You can always use the Send to option to share it with your teacher and your peers. Now it's time to bring all our required components into the circuit. The first important component is the Arduino board. You can use this rotate option and keep the board in whichever position you like. Next important component is the breadboard. We would be in need of three different LEDs here. And to protect the three LEDs, we want three different resistors. Next, we would require a soil moisture sensor. With this, all the required components are brought to your workspace. Now it's time to give the connections. The ground of the Arduino is connected to the negative of the breadboard. Always give a black wire color whenever the grounding is involved. I'm just going to rotate this LEDs so that it sits properly. You can connect to either any rows. Next, today I'm going to do a project where I have three different colors in LEDs representing the three different soil. So let me take red, yellow, and green. All the cathodes of the LED should be grounded. Now it's time to give connection to the anode of the LED. Let's start with the red one first. The red LED is connected to pin 2. The yellow LED is connected to pin 3. I'm changing the colors of the wires so that the visualization is better. You can use the same color wire too. For the green LED, I'm just going to give a green wire color. So, red LED is connected to pin 2, yellow to pin 3, and green to pin 4. That's it. With this, the LEDs are connected to the Arduino. Now, it's time to connect the soil moisture sensor with the Arduino board. A soil moisture sensor has 3 different pins: VCC, ground, and signal pin. Let's give the ground connection first. The negatives of the breadboard are connected together so that you can give the connection here directly. Next, we have the VCC and the signal pin. VCC and signal are the 2 important pins which needs to be connected to the Arduino board. Let's start with the signal pin first. The signal pins can be connected to any of these analog inputs. I'm going to connect it to the A0 pin. The signal pin of the soil moisture sensor, I'm going to connect it to the A0 pin of the Arduino board. Next, we have the VCC pin. VCC is the power pin. We are going to connect the power pin to any of the digital inputs of the Arduino board. I'm going to connect to pin number 8. You can connect to any of the pins. Well done. The connections are done. Now it's time for us to go to the coding part. Let's make the circuit come alive using coding. The Arduino will read the sensor value, compare it with the preset range, and decide which LED it should turn on. So let's go to the coding part and click text. Then click continue. Erase the already existing code and try paste the code which I have shared with you. You can find this code in the handouts too. In coding, the first important part is variable declaration. You're going to tell the Arduino board what variable you are assigning and you're connecting to which pin. Arduino works depending on what kind of instructions we give to it. Int soil moisture pin A0. So moisture sensor pin. So this is a variable name what I have given. You can give any variable name. Be sure that you're using the same variable name throughout your code. All the variable names are case sensitive. So please be sure that you use the lowercase or the uppercase throughout the code to avoid the errors. Moisture sensor pin. That's the name what I have given for a variable. So a soil moisture sensor has 3 different pins as we know already, a VCC pin, ground and a signal pin. I have connected the VCC or the power to the 8th pin of the Arduino board, as you can see here. And I have connected the sensor pin to the A0. If you are willing to connect to A1, ensure that you are changing to A1 in the code. Int red LED, yellow LED and green LED. I have connected my red to 2, yellow to 3 and green to 4. Int sensor, int wet is equal to 800 and dry is equal to 500. Wet and dry are the threshold values and they decide what counts as wet or dry. And the variable sensor is going to store the real-time sensor reading. Sounds interesting, right? Yeah. Next, let's go to void setup. This setup function runs once at the beginning, and we tell the Arduino that all the LEDs are the output device. All the LEDs are output devices. So you can see red LED output, yellow LED output, and green LED as output. And we are connecting the soil moisture power to the output pin. Serial begin 9600 is going to start the communication with the serial monitor so we can see the sensor reading as numbers. Next, let's move to the void loop. Sensor is equal to analog read moisture sensor pin. So what we are doing exactly in the loop function is the Arduino reads the sensor which is being connected to the A0 pin, and the values are between 0 to 1023.